Okay, let's dive into this. Have you ever wondered why the very first bite of your absolute favorite food tastes just heavenly, but by the time you're forcing down that last bite, it's kind of just meh? Well, welcome to this explainer. Today, we're going to completely unravel this universal mystery using a massive cornerstone of economic theory. We are doing a masterclass on the law of diminishing marginal utility.
To make sure you absolutely nail this concept, we're strictly dividing this up into three distinct steps. First, we'll cover the statement of the law. Second, the core conditions, or the rules of engagement. And third, we'll look at the visual proof with the marginal utility curve.
All right, Section 1, Statement of the Law. To build our foundation here, we have to look at the words of the legendary economist Alfred Marshall. He stated, quote, "The additional benefit a person derives from a given increase in his stock of a thing diminishes with every increase in the stock that he already has." Okay, let's translate that academic speak into plain English, right? Essentially, it just means that the more you have of something, the less satisfaction or utility you get from consuming just one more unit of it. That intense initial desire you had, it literally fades with every single additional serving.
Moving right along to Section 2, the core conditions.
So, the crucial point is that for this economic law to actually work, it requires a heavily controlled environment. You can't just apply it randomly. The very first assumption is the homogeneity condition. This means every single unit you consume has got to be absolutely identical in size, shape, and color. You can't switch things up halfway through. Like, if you're eating mangoes, they must be the exact same variety and ripeness. Because think about it, if your second mango is somehow sweeter or juicier than the first, your satisfaction might actually go up, right? And that totally breaks the rule. Total uniformity is required. Next up is the continuity condition. Every unit has to be consumed in quick succession with zero time intervals. Absolutely no breaks allowed. If you eat one mango for breakfast and then another one after dinner, well, your appetite is totally reset by then. For this law to hold true, the consumption has to be a continuous, unbroken chain. Then we've got the constancy condition. While you're in the middle of consuming these items, there can be absolutely no change in your personal tastes, habits, or preferences. Your entire psychological profile is essentially locked in place during the experiment. Because if you suddenly develop a weird new craving halfway through, the data gets completely thrown out the window.
Now, this next one is actually kind of funny. It's the reasonability condition. The text gives a very specific warning here. The units you consume must be a standard normal size. So consuming a full mango? That's correct. But eating a tiny bite-sized sliver of a mango? Incorrect. A proper cup of tea works perfectly, but trying to drink tea from a teaspoon doesn't. And the reason is simple. If the units are just absurdly small, your satisfaction might actually increase with the next few units simply because you're getting frustrated and you just want a real proper serving.
And we wrap up these strict constraints with two major assumptions: rationality and cardinal measurement. First, we assume our consumer is a completely logical, rational actor whose sole goal is to maximize their own satisfaction. On top of that, we have to assume that utility, that fuzzy feeling of satisfaction, can actually be quantitatively counted in exact numbers. Economists call these units utils. I know, it sounds a bit like sci-fi, taking a human feeling and assigning a hard number to it, but it's absolutely necessary so we can map out the math.
Which brings us to Section 3, the marginal utility curve.
Now that our theoretical constraints are locked in perfectly, we can dive into the hard data. Just look at the journey we go on here when we map out this continuous mango eating contest. That very first mango, it delivers a massive, glorious high of 10 utils of marginal utility. But check out what happens next. The second mango only adds 7 utils. The third drops down to 4, and by the fourth mango, you're getting a measly 1 extra util. So your total utility is technically still growing, sure, but that additional satisfaction, the marginal utility, takes an agonizing drop with every subsequent mango in that chain.
And this brilliantly illustrates the exact phenomenon visually. Trace that downward slope from left to right. It is literal visual proof of Marshall's law. As your stock of a thing increases, your extra satisfaction just plummets.
But keep following that downward line, because right at the consumption of the fifth mango, something really significant happens. The marginal utility physically hits zero. Economists call this the point of satiety. At this exact coordinate, your total satisfaction has reached its absolute maximum limit. You are perfectly full. You're completely satisfied. That mango has zero want-satisfying power left to offer you.
Let's move to and see how this builds if you completely ignore your body's limits. What happens if you blow right past the point of satiety and force down a sixth mango? Well, the schedule and the curve show us that the marginal utility doesn't just sit at 0, it physically breaks through the axis down into negative numbers. At -3 utils, you are no longer gaining satisfaction, you're experiencing active dissatisfaction. You're uncomfortably stuffed, you're probably feeling sick, and the utility has gone completely in reverse.
So look at that. We've gone all the way from an academic rule, through the strict assumptions, right down to the downward-sloping visual proof. You now possess a highly powerful economic lens to view human behavior through. So I'm going to leave you with this. How will you spot the law of diminishing marginal utility happening in your very next meal, or maybe your next big purchase? Keep an eye out for that dropping curve in your own everyday life. Thanks for joining me in this explainer.